Okay. Okay. Yep, go ahead and get your stuff. And we are going to, we've been talking about the experiment. Nope, don't start. Get your stuff, put it in your basin, and put everything down. Braylon, put it down. Okay. When you are done and you have your supplies, I want you to sit down. Hold your hand up with the thumbs up and show me you're ready. All right. A lot of students are ready, but I see a couple that still need to sit down. All right. I need all eyes up here. Okay. So we have been talking about matter. Who's going to tell me what matter is? Raise your hand. Braden, what's matter?
Anything that physically
Yes, something that you can as physical substance that takes up place, right? Okay, space, not place, sorry. Okay, there are 3 states of matter. Raise your hand and tell me one of them. Give me one. Gas, solid, liquid. Give me an example of something that takes that experiences the 3 states of matter. Water. Give me the solid of form of water. Ice. What's the second one? What is it? What's the liquid? What is it?
Water.
Just water. Okay. And what's the third one? What's the third one? Or gas. Yes, very good. Okay. So when we did our experiment, can somebody raise their hand and tell me what we did? We made a what? The one that we did back here. What did we do? We made a solution. And Braden, what's a solution? What's a solution? Help them out.
When 2 substances or more are mixed together, they cannot mechanically be separated.
Yes. When 2 substances, what's one substance? Salt. What's the other one?
Water and
Water.
salt and water can be separated through a gravity. It's separated mechanically.
Okay. Very good.
It makes it nicer.
Okay. Well, in this case, it is because we can't, like Aiden said, we can't mechanically separate it, right? So what did we use to separate? What did we do?
We use evaporation.
Evaporation. And what is evaporation? Raise your hand. Taylor, what's evaporation?
When a liquid raises up and
Okay, turns into a gas, right? It goes from a liquid to a gas. Okay, so talking about this, we had one of our supplies was solid. What was it? Emily, what was it? Okay. Or this experiment. The salt. Good job. And what was the liquid? Olivia. Water. Very good. Okay. So we talked earlier about the different descriptions that you looked at for your salt, right? Okay. Who gave me this one? This table. Okay. Can you explain that to me?
Like when you look at it, there's like little shiny, glittery pieces.
Yeah.
Yeah.
Okay, so the light hits the salt and it makes it sparkly or shiny, right? Which table gave me this one? Tell me about it. Tell me about the crystals. Okay, class.
Yes.
I was talking to a student and I couldn't hear her because there was talking in the background. Okay, I need voices off. Okay, so you were saying that it looks like crystals because what? the third one, frozen or solid. Table 3. Can you explain that?
Usually salt. If you take the lid, it won't like go down. You use salt.
Yeah, because before, oh, I need voices off, please. Because before it was just all separated, right? And now what is it? It's kind of all,
Or like stuck together.
it's hard and stuck together, right? Good. Okay, who was talking about the design? Table 2, tell me about the design.
When you look in the middle of the cube salt, and it looks like two crystals. It looks like a crisscross in the middle.
Okay, yeah, so it gave it a kind of a texture or a design, right? And what did you say that it looked like? A snowflake, because it had the pattern, right? Okay, table 1, what did you say about it?
We said that it looks thick and thin, and because like sort of like around like in the inside, like when you put the paper under, you can see through it. Then like the thicker ones, you can't really see through it.
Yeah, so it had a different consistency to it, didn't it? It was thick on the outside and it was thin on the inside. Very good. Okay, so yeah, you guys, you hit it exactly where I wanted to go with that. With the crystals. So what is a crystal? Somebody raise your hand and tell me what a crystal is. Really, what's a crystal?
It is something that is shiny, and it has a pattern, and it has atoms, and whenever it's pattern, depends on how many atoms are joined together to form something.
Okay, yeah. A crystal is a solid form because your salt is solid, right? Because it was dissolved. Yep. And now it's a solid. It's a solid form of a material. What's the material, Braden? What material?
Crystal is also
Okay, very good. What is this solid? The solid material is the salt, yeah. And it can be identified by its special shape or pattern, like you said, right? And that is also going on the design that one of the tables said about how it looks like a snowflake, right? Okay, so what we are going to do is we are going to watch a video about crystals.
Hey Bob, could you do an experiment with crystals? That would be awesome. Thanks. From EXPX. Dear Tim, please do a movie on crystals so I can do my experiment. From Bob. Well, this should make Bob happy. Most people think of jewelry when they hear the word crystal. But there are lots of other types of crystals too, found all over the place. We even eat crystals. Salt, sugar, and baking soda are all crystals.
What are
Technically, a
crystals?
crystal is any solid molecule arranged in an ordered, repeating pattern. More commonly, people usually talk about crystals when they mean to say a mineral with some geometric shape to it. In fact, most solids are made up of lots of tiny crystals. If you look at a rock closely, you may be able to see them. Crystals can be made from different elements. Diamonds are made from carbon, and salt is made from sodium and chlorine. A crystal's color is determined by the elements mixed in. Quartz can be transparent, milky white, pink, yellow, or even purple when they have a lot of iron in them. The shape of the crystal depends on the way the elements group themselves together. Crystals actually grow in orderly geometric shapes as new atoms join the organized crystal lattice. The individual atoms combine in regular geometric shapes, shapes which repeat themselves in the shape of a large crystal. Those shapes aren't so obvious in tiny rock or salt crystals, but crystals that grow freely in rock cavities and caves are bigger and more precise in shape. The atoms are arranged so perfectly that crystals break along clean lines called cleavage. There are 7 main types of crystals: isometric, trigonal, hexagonal, tetragonal, orthorhombic, monoclinic, and triclinic. Scientists
How many?
7.
use X-rays to examine the crystal lattice of a particular specimen and place the crystal into one of those groups. Yeah, real nice. I don't know if rubies are you. There are also liquid crystals that are like gels with both liquid and solid qualities. They're used in things like calculators and CD players. By running an electrical current through layers of these crystals, you can cause them to display letters, numbers, and images. Moby? Ah, cave monster! Well, now you've done it.
Okay. So what did it say that salt? What is salt made up of? What is salt? What is it? Sodium chloride, right? Have you heard of sodium? Like in class?
Yes.
Okay. What I want you to do is I want you to, oh, I need voices off. I need you to take 5 milliliters of water in your syringe. How many? 5 milliliters, and you are going to, can you sit down, please? And you are going to put it in with your salt. Okay? Now, where should your salt stay?
In the basin.
In the basin. Because if you're holding it and you put water in, what may happen? What may happen?
It may spill, and also, do you want to find more?
Yep. If you're holding it, you might drop it, it might spill, and then your experiment is done, right? Okay, so make sure that you put 5 milliliters of water in. Yes,
We're done.
you're done. Okay, give me a thumbs up if you are ready to go on. Okay, very good. Okay, now what I want you to do is I have a sheet that I want you to record what we have done on here. Okay, so you are separating a solution. That is what you've been doing, right? Okay, so the first time we did this, you put 50 milliliters of water, right? And then what happened? What did we do? What did we do? Natasha, what did we do? We mixed it in, we let it set, and what happened? It evaporated. Right. Okay, so you are going to fill this out, and you may use your notes from last week that told how much everything weighed. I want you to fill this out, and then what I want you to do is I want you to notice the changes now that you've added water back in, and I want you to write those down, okay? I'm going to put these at the back table. I'm going to call you by tables, and you can come get one. Everyone needs one. All right, table number 1, come get one. And then once you've got your sheet, go back to your desk and start filling it out. Yes. Oh, you're ready? Thank you. Thank you for giving me a thumbs up, showing me you're ready. All right. Okay, group 2. Go get your sheets. All right, group number 2. Oh, I'm looking for tables that are ready. All right. Natasha, your table looks ready. I need a thumbs up. Show me that you're ready.
Okay, Miss Blay is videoing,
Oh,
so if you want, you gotta watch it and make sure that the screen doesn't go black.
okay. Okay. Breland table, go ahead and go get your worksheet. Your graphic organizer. You ready? Okay. All right, table number 3. Go ahead and go get your sheets. And you may use your note. Okay, go ahead and grab your papers and head back to your desk. All right, we are going to, we're going to stop there. Tomorrow you can continue to work on your sheet and fill that out. And we are going to, if you would please have one person take your dish and place it over there nicely without spilling it. For the classroom management assignment, I anticipated behavior issues and chose to implement the behavior management technique used by the school I am student teaching in by saying class, class. The class then replies by saying yes, yes, indicating that the students are focusing their attention on the teacher and are ready for instruction. All of the classes in the school that I am student teaching at use this behavior management technique so that the school is all on the same page for classroom management. When the teacher gives this classroom management cue, the students know that they should stop what they are doing and their voices should be off. Another behavior management technique I used was by instructing students to hold their thumbs up, indicating that they are ready to proceed with the lesson. I chose to use this as a behavior management technique during the lesson because if students did not show me they are ready by putting their thumbs up in the air, students often get behind in the lesson, which causes disruptive behavior in the class. If students do not follow along and let me know they are with me, a group of students may get behind in the lesson and not know what to do next, causing delays in the lesson and possibly disruptive behavior of the students that are waiting on those students. By having students hold their thumb up in the air to show me they are ready to proceed with the lesson saves time and confusion. I also reminded the students that I needed their attention focused on me to get them engaged in the lesson by telling them I need their eyes on me. The classroom management challenges that arose during the lesson included having students talking during the class discussion. I had a student that was answering a question and I could not hear her because of the conversation students were having that was unrelated to the topic. I handled the classroom management challenges by telling the class that I needed their voices off because I was unable to hear a student that was participating in the class discussion. We've had this conversation before that we need to be respectful of our peers, and if they were talking to the teacher, that they would want me to be able to hear them. I also had students get up from their seats and try to proceed with the lesson without hearing all of the instructions or directions. When this happened, I had all students sit back down until the directions were given, and then I let the students know I was done talking and they were free to proceed with the lesson by saying go. If I do not say go, students try to get up and start without listening to all the details and instructions. I also had students that were off task and not paying attention during the lesson. To get them back on task, I simply used proximity to walk past them and get their attention to get them focused again. I like the approaches I used during the science lesson. Students get excited to participate in hands-on activities and experiments, and I want them to have fun doing it. However, there has to be stability and structure in the classroom to make the lesson successful. Based on the teaching experience, in the future, when the class gets too loud during a lesson, I may change my classroom management technique from having the students say yes, yes when I say class, class, to saying in a regular tone, if you can hear my voice, clap once. If you can hear my voice, clap twice. By using this technique, I'm not talking over the students, but still getting their attention by having the students that can hear me reply by clapping. When the other students hear the clapping, they will know I need their attention and focus their attention on me.